Write down my first different types of forces. In mechanics, asking only in mechanics. Okay. There is electrostatic force, magnetic force. There are many forces, correct or not? I'm asking only in mechanics. Mechanical forces. First one, what did you tell? Gravitational force. Second one,
Normal force.
normal force. I'll explain what are those forces, everything I'll explain. Just give me the list properly first. Third one,
Magnetic force.
it's not a mechanical force.
Okay.
Give me a
Frictional force.
frictional force, correct? Frictional force. Next, fourth one,
Restoring force.
no. Fourth one,
Force after collision.
no. Ilma, you need to tell. Come on.
Pseudo force.
No.
Force of tension.
Tension. Yeah. So there is a reason why I am denying certain forces, whatever you are talking. There is a reason why I am denying. Okay. Whenever you think of this lesson and you will be drawing so many diagrams, in the diagrams, I want you to remember these forces. These are the forces first come in mind. Pseudo force why I didn't tell, I'll tell you. Okay, next one. Next, come on, keep telling. There are infinite forces, okay. I am just limiting you towards the like this 11th syllabus, whatever you have, or up to what for you have to learn. I don't want you to bring all the forces and confuse you. Okay. I just want what are the first basic part of forces you should remember so that you will handle loss of motion very properly. Fifth one. You told almost good things. Okay, almost good thing. Last one is maybe I think you can take it as centripetal force. Centripetal force came, right? The like when the body takes in circular motion or any curve motion, if you take, then centripetal force will come. Any curve motion. What is force, ma? What is force? Force is what? What is force? What quantity it is? Force is what quantity, ma? Vector, right? So it will have magnitude and direction, correct? In this page, I'll give you magnitude. Next page, I'll start giving directions. Clear or not, ma? Okay. Yeah, magnitude. How to calculate gravitational force? How to calculate gravitational force? Gravitational force I'll represent with W from now. Okay, gravitational force is nothing but weight. Gravitational force on the body is nothing but weight. I'll represent with W. How to calculate it, ma? How to calculate it? Gravitational force acting on you. Come on, fast. Silly questions. If you don't answer fast, how will you answer further things? Come on.
G square.
What, ma?
G mm by r square.
Okay, that is okay. Correct, but simply that formula has short form also, that is simply mg. That is correct, ma. That is just expanded version of this formula. Okay, these two formulas are same only. Mg and gmm by r square are same formulas only. That's like even more. That formula will help you calculating gravity. Like I mean, that's an actual formula of gravitational force, but we won't be using that. We'll simply use mg, which is shorter form of that force. Next, normal force. Normal force I'll always represent with letter n. Normal force I'll represent with letter n, but there is no formula for it. Clear? There is no formula for it. Then how will how will you calculate its value, sir? I'll calculate with the help of other forces. Okay. Suppose if your mass is I told you you are sitting, right? You are sitting, right? Two forces are acting on you, no ma. Two forces are acting on you, right? What are the two forces? One is weight, other one is weight vertically. How much weight? Suppose if you are 50 kg, how much weight will be acting on you, ma? If you are 50 kg, if you are 50 kg, how much gravitational force will be acting on you?
60 Newton.
No, it will be 50 into 10, correct or not? 50 into 10, m into your mass into gravity we should do, right? So 500 Newton force will be acting on you due to gravity. And as she was saying, normal force will be upward. So how will I calculate normal force value? Means normal force is balancing what, ma? Normal force is balancing gravity, right? So I'll say normal force is 500. Understood or not? Normal force doesn't have a formula. We'll calculate its value with the help of other force balancing, or when we write equations, we'll get its value. Clear, ma? Any doubt? Next, frictional force formula. Anybody frictional force formula? Friction force formula.
U.
Tell, ma. Somebody's telling. Tell.
U.
Good. Friction formula is mu into n, ma. There is lot of friction is not an easy thing. It's not at all an easy thing. You need separate lesson for it. I mean, simply mu into n, what is that n? And there is a lot of understanding behind it. Okay. See, suppose if you take a spherical body, on that weight is mg, correct or not? If I take square body, on that also weight is mg, but friction force will be different. Friction will act differently on different shapes. Are you getting it? What I am saying? Why for everything, if you want to move something, heavy object, generally we'll select what? Bottom. What will we select, more? Any heavy thing you want to move, whether it is fridge or washing machine or car, anything. What do we select, ma? At the bottom?
Wheel.
Wheels, correct or not? We prefer rolling, correct or not? So because rolling friction will be very less compared to the other friction, rolling friction will be compared to static friction, rolling friction will be very less. So friction is a very big subject. Remember, friction basic formula is mu into n. Friction basic formula is what, ma? Mu into n. I'll be discussing 2 classes. I'll be discussing on friction, but right away you need to apply mu into n formula. Okay. Next. See, you might be in some wrong thing. That normal force, you will be like so many times you'll get you'll go into wrong impression that n is always mg. N is not always mg, ma. N is not always equal to mg. It depends on how it's orient. We'll see. N doesn't have formula, remember. Tension also doesn't have formula. I represent with T. Tension also doesn't have formula. I will represent with T. And this is also calculated using the support of other forces. Centripetal force formula.
mv square by r.
mv square by r formula. mv square by. How will I represent centripetal force? Means, yeah, we'll simply draw it as directly. You can draw it as mv square by r. I won't represent with any letter, or you can write as fc if you want. Got my magnitudes? You'll remember these formulas. Should not irritate me later, please. Weight is mg, which is very basic formula. Friction formula only, I think you learned mu. Mu into n. Mu into n. Mu. It's called mu into n. Mu is coefficient of friction. Shall we go to directions? Okay. First gravitational force. Gravitational force directions. These diagrams are very important. Whatever I am going to draw now, they'll be very useful when concept clarity will be there. Right. First gravitational force. Draw the diagrams properly. Fast you can draw. Okay, don't take much time. The situations you will face is either the body will be lying on the ground like this, or the body will be sticking to the wall like this. Or body will be lying on an inclined road like this. The different situations you will face. Okay. Or the body will be hanging in the air. Understood, Amma? 4 things. What are the 4 things? Body lying on same. See, all lessons I am categorizing the same thing: horizontal, vertical, inclined. Same thing. Even motion also I saw it in the same way. Okay, the body lying on horizontal road, body lying on vertical, like vertical road, obviously wall, right? Body lying on the inclined plane, and body which is hanging in air. Yeah, on this gravity will be what direction, ma? What will be the direction of gravity? First, gravitational force direction. These diagrams will bring you clarity. Don't neglect. If you think you already know it, you are mistaken. I'll tell you some important points. Please focus. Tell me. How will be the gravity direction, ma? What is the gravity direction?
Vertically downwards.
Vertically downwards, right? So always vertically downwards, ma. Most always vertically downwards. If you face any issues, I will tell you, but it's always vertically downwards. It's vertically downwards. Yeah. So vertically downwards, see W. When I am drawing, one more important point. Where I am drawing, where I am starting the vector direction.
From the center.
From the center of the body. That's important. Actually, we call it a center of gravity. It varies from shape to shape. For this shape, it is for square or whatever we are taking, it will be vertically downwards. See, even in inclined plane, if you are getting confused, I'll show. See, inclined plane center you need to select, put it vertically down. Clear, ma? Understood? Please draw with different colors. Even if it is hanging in air, then also gravity will be there, because gravitational force is not. Gravitational force is not what, ma? Gravitational force is not a. Anybody? Even
Contact force.
not a contact force. It's not a contact force, ma. Their contact is need not require, the body need not be in contact with something to have gravitational force. Even if you are in the air within the region of the gravitational field, then definitely gravitational force will be there. Only one case la gravitational force will not be there. Where, ma? Only in one case gravitational force will not be there. Where?
When the body slide.
No. Yeah.
Vacuum.
Yeah, even lighter bodies also gravitational force will be there, correct only, but it will be very, very feeble. Okay, it will be there. Tell me, when complete gravity will not be there?
In vacuum.
No. Tell me. Tell me. Simple only, ma. I'm asking very simple question. Come on. Like after telling answer, you might scold me. Like, okay, if you escape Earth's gravity, correct or not? That means in space, correct or not? Suppose if they tell the body is in space, then you should not draw gravitational force. Clear or not, ma? They say like body, suppose it escaped Earth's gravity. This is Earth means its effect will be there until some certain level only, ma. Beyond that, its effect will not be there. If you are within this region, then only gravitational force will be there. If you go beyond that gravitational force, you should not draw on that body. Understood or not, ma? Okay. Within the region, see, even magnet also same, right? Magnet also what? It can attract magnets, which is within the region of magnetic field, correct or not? If you keep it far away, it can't attract, no. So same way, Earth also will have the limit of its gravitation. Beyond that, it won't attract. Where like you see, like we call it as space, where gravity will be zero. Okay, I wanted to draw one more figure. I forgot to draw. One more figure. Suppose if beaker is there, in the beaker water is there. What if body is inside the water? Then gravitational force will be there or not? Tell me. There is a beaker, inside water is there. Inside that, if I draw, like, yeah, if I put a body, it is floating, gravitational force will be there or not?
It will be there.
It will be there, ma. Draw. How it will be there, sir? Vertically downwards. Always vertically downwards. Got it, ma? Clarity on? Okay. How to calculate gravitational force in all these situations? How to calculate its value in all these situations? How to calculate value of W in all these situations?
mg.
Just multiply its mass with the gravity value. Clear or not, ma? Earth means you will take 9.8. Moon means you will take 1.6. Correct or not? See, I'm you should draw it accurately. Maybe in school they will not mention like gravity. They will draw however they want, but it will affect in rotational mechanics. So please, now itself I am being careful how exactly you should draw. You should draw gravitational force vertically downwards from the center of the body, and it's a what, ma? Non-contact force. You don't have to require contact with anything for to show effect of gravity on it. Then shall I move to next one? Clear gravitational force, you got clarity, right? Okay, next go to normal force first. Normal force. Next, normal force. I'll not have this notes later. Everything will get wiped off. Please copy it properly. I'm telling you, it will help you a lot. Again, same situations. Again, same situations. Again, same situations. Yeah, tell me. These 4 cases, how will be the normal force? What is normal force direction? What did she say? She told it's
Upwards easily.
normal to, no, it's not always upwards. That's the problem. Normal to the contact surface or perpendicular to contact surface. Perpendicular is not a, see, when two lines are perpendicular, we use that. But when a plane and line is there, no, generally we don't use perpendicular word.
So it's tangential, right?
No, normal to the contact surface.
Which is technically the same, right?
I'll show it. Tangential means it will be, I mean, tangent word itself. Which one you are talking about? Normal, huh?
Yes, sir.
Normal and tangent are not same.
No, I'm saying normal force will be
No, it won't be tangent.
perpendicular to the tangential force.
What is tangential force?
Force acting on the body by the plane or whatever it's on.
Here, how will you draw tangential force? First case law.
That's what I wasn't sure because that's what my
Yeah.
teacher said. He said
Okay.
it's tangential force.
I am telling, no, wherever contact surface is there, what you should do? You should draw perpendicular to it or normal to it. Normal is the specific word. Sir, why are you not using perpendicular word? Means two lines are perpendicular. Perpendicular word is for two lines. But when you talk about a plane and the body, generally we call it as normal. Clear or not? When you draw a line to when you're drawing line to a surface, we use word called normal. Clear, ma? Terminology okay? Fine. Okay. You can remember perpendicular, no problem. Perpendicular to contact surface also is fine. But it's not exactly correct. See, contact surface is like this, right? Contact surface is like this, right? If you want me to visually draw it, actually plane is like this and then body is lying on it like this, correct or not? Okay. So how is the contact surface? I have drawn a red line. No, that is a contact surface, correct or not? Contact surface ki perpendicularly you should draw. Contact surface ki you should draw perpendicular. You put contact surface line and then you draw line perpendicular to it. What is one more point you should notice in my diagram? What is the one more point you should notice in my diagram? What is the one more point you should notice in my diagram?
It is not from the center of the object.
Yeah, you should draw from the contact surface. It should touch the contact surface. You should not draw it on the from the center of the body. You should not draw. If somebody, if they keep something like this, then it's okay. You neglect them. Okay, but normal force actually, you don't try to educate them. You just leave it. Normal force, you just maintain that thing that it should touch the contact surface. Clear? Okay. Next. Here, how will be the normal surface? It will be upward here. Second case law. This is second case. It will be up. It will not be upward. Correct or not? Can you tell me it will be left or right or up or down? If you draw perpendicular to contact surface, will you get left or right or up or down?
Right, sir.
You get right, correct or not, mom? Because this is the contact surface. Again, I am showing. See, this is the contact surface, and you have to draw normal force like this. Understood? Easy only, no, ma. Contact surface ki perpendicular you should draw. That's it. Then third case, this is the contact surface. This is the contact surface. You should draw normal force like this. Correct or not? Fourth case law will be the normal force. Fourth case law now will be the normal force. Fourth case law will be the normal force. Tell me, Ananya.
So there will be no normal force.
Yeah,
It's not
normal
in
force will be
contact.
0, ma. Normal force will be 0 in fourth case because it is not in contact with any body, not only ground. Not only ground, it is not in contact. I told it is just hanging, right? It is just hanging. If it is contact with some other, but contact is not there. No, it is contactless, right? At least normal force due to earth is not there because it is not in contact with earth. Clear or not? If it is contact with some other body, then suppose if it is in contact with ceiling, let's say something is sticking on the ceiling of your room, then that will have contact force, but it will not have contact force. That normal force it will have, but not due to the earth. It will be there due to the ceiling. Wherever body is touching another body or another surface, their normal force will come, but they have to touch. It's a contact force. Contact is there means then only it will be there, or else normal force will be 0. Clear, ma? What if body is saying no beaker water is there inside body is there? Then what about normal force here? What about normal force here? It's not in contact with, first thing, it's not, is it in contact with beaker or not? Is it in contact with beaker or not? If it is completely going and touching the bottom, then normal force will be there, correct or not? Okay. Now normal, it is in contact with what? It is in contact with what? Sorry, you told no, whenever body is in contact with something, normal force will be there. Yes, correct. But now it is not in contact with beaker or ground, so it doesn't have normal force. But it is in contact with what?
Water.
Water. Then force will be there. But we don't call that force as normal force. We call it as anybody.
Buoyant force.
Yeah, Buoyant force, but pressure. Okay, pressure. If you sum up all the pressures, you will get buoyancy force only. Buoyancy force is net sum of we'll discuss in fluids. We'll discuss, but it is in contact. Whenever body is in contact with liquid, don't think body and liquid are in contact. No, sir. So contact force will be there or not? It will be there, but it's not normal force. We don't call it as contact force or normal force. We consider it as pressure. Clear or not, ma? Any doubt? We don't bring normal force concept between solid and liquid. Between solid only we see that. Done. So don't draw normal force when the body is floating in. When the body is floating in water, don't draw normal force on it. There will be force due to contact of the liquid. That will not be normal force. That we call it as normal force. Clear? So what is the direction of normal force? What is the direction
Perpendicular to the surface.
Perpendicular to the contact surface.
Contact surface. Yes.
Contact you have to see, ma. You have to see the contact. There are many cases actually, many cases, and you have to learn it too much. Sometimes I want to show the diagrams. Sometimes you might face. I'll give you one more situation. See, suppose body is lying in the corner like this. Then ma. Body is lying in the corner. It is in contact with what? It is in contact with what?
Two surfaces.
Both wall and ground. Okay. Then will we have two normal forces? We'll have two normal forces. Okay. One we have to draw N1 like this. One you have to draw N2 like this. Understood or not? Understood or not? This is the contact surface. I draw perpendicular to it. This is the contact surface. I draw perpendicular. N1, N2, two normal forces will be there. Wherever contact is there with some surface, it is in contact with two surfaces. One is base, other one is wall. So two normal forces will come. Two normal forces will come. Any doubt? Drawing forces, if you, I am telling these many examples, this much clarity I am trying to maintain because you should not trouble me later, okay? Please, later on directly I'll draw the force. I will not explain why did I draw like that because I have lot of other things to tell, okay? Please maintain clarity now itself. Done, ma? Clear? Shall we go to next force? Fast. Friction. 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 What is the direction of friction? What is the direction of friction?
Opposite to the direction of motion.
Opposite to the direction of motion is okay. Opposite to the direction of motion is okay, but it will get upgraded. Anybody want to tell that upgraded thing you would have learned? Opposite to the direction of anyone? Simply, if you write motion, they'll cancel out. It will be wrong statement in 11th. Okay. If you write opposite to the direction of motion, it will be wrong. It's not if they won't accept it fully. Yeah. Can you tell upgraded statement, anybody? Opposite to the direction of relative motion. Relative motion, we say. Why means we'll discuss that later. Again, now we can't give you that much clarity. Because I don't want to give you the statement and later on, like, if you think that statement is correct, it will be wrong. It will get upgraded. Opposite to the direction of relative motion answer. Relative motion we studied, right? What is relative velocity formula? VAB. VAB formula is what, ma?
VA minus VB.
VA minus VB, that thing will come. If one body is static, other body is moving means, then what you said is correct. Understood, ma? Suppose ground will be at rest, right? Body will be moving, no, towards right, then friction will be left. That is correct. But both the bodies are moving means, then friction you have to be careful. Clear or not? It might not be in the direction of motion. Understood, ma? Okay. Opposite to the direction of relative motion. That is the thing. If you want me to tell in, we can't understand this one in one way. Another way is it is tangential to the contact surface. Tangential to contact surface friction. Last time, what did I say? Last time, what did I say? Last time, what did I say?
Normal to the contact surface.
Yeah, normal to the contact surface. Now I am saying tangential to the contact surface. Draw all the diagrams first. Clear, ma? So this is the contact surface means this is the contact surface, right? I must draw direction of motion or else I can't draw friction. Correct or not? Correct or not? I need to draw extra arrow mark. Then only I can draw friction. Correct or not, ma? That was not there in previous two forces case. That issue is not there. Sir, what is loss of motion lesson? Loss of motion lesson is, first point is you need to how many forces are acting on the body. You need to identify the forces. Second thing is you should draw the forces properly. Third thing is you should apply the equation. That's it. These 3 steps only. That only I'm trying to make you excel in it. Okay. So that's what. How much you study, no use, textbook. You have to follow this. Suppose body is moving right, then it will be what, ma? Friction force will be towards left. One more. You need to observe point properly. How did I draw friction force? Friction force will not act on. Friction force will not act on what, ma? Frictional force will not act on. How did I draw, ma? How did I draw? Gravitational force, how did I draw?
Center of the object.
From the center of the object. Normal force I drew from the contact surface. Frictional force also I am drawing at the contact surface. I am not drawing through the center of the body. It won't act on the center of the body. Clear or not? Again, if you see some situation, somebody drawing like this friction, neglect. Okay, neglect. Don't do it. Okay, friction you have to draw exactly to the contact surface. Tangential you have to draw. Here, ma. Frictional force, how it will be? Left or right or up or down? Second case. Left or right or up or down? Sir, you didn't give me direction of motion. Yes, but naturally body will come which side, ma? Naturally body will be going natural.
Downward.
It will be downward, correct? Generally. Sir, it doesn't have to. Spider-Man will go upward. No, yeah, it will go. Some things will go upward. No, some snails and all will crawl upwards. No, correct only. If snail is crawling upward, then snail or lizard will be crawling upside, no, ma. Then friction will be, friction on it will be
Downward.
downward. Okay, but naturally, if some body is on the wall, then on that frictional force will be what, ma? Upside. Clear or not? Next. This also tell, ma, natural motion. Naturally, it will try to slide. Naturally, it will try to slide. Okay, I'll put it. I'll put the direction. No problem. Black mark. I'm putting the direction. Sir, inclined plane. You told direction is always up. No, ma. Inclined plane. If the body is moving, inclined plane. If the body is moving, on the inclined plane, if the body is moving upward, then friction will be downward. Clear? Fourth case, lama friction. Fourth case, friction.
No friction.
No friction. Zero, ma.
No friction, sir.
Friction is a contact surface. What about the body floating in liquid? What about the body floating in liquid? What about the body floating in liquid?
No friction.
No friction. Instead of friction, there is something called viscosity. Understood or not? Viscosity, viscous force only. Viscous force is like friction force only. It is friction due to fluid. Viscous force you will observe whenever you are trying to. It's difficult to move through more denser fluid. Correct or not? It's easy to move through less denser fluid because due to friction, or there are many other factors also. Viscous force is there. There is friction. There is friction exists in fluids. That is viscous force. Okay, we don't call it as friction. We call it as viscous. It's a form. It's just another form. Any doubt, ma? So what is the direction of frictional force? It's not up or down or left or right, ma. It depends on how the body is in contact with the surface and which side it is moving. Got it or not? Which side it is moving, that only. Shall we go to next one? Yeah, next. Tension. 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 When tension you will see means, you will see only in strings, ma, or else no need to see. Tension will be there. Mostly you will come across in strings only. Whenever you see some rope or something, then only tension will be there, because till now I haven't drawn any tension. See, tension, how to draw means, how to draw tension means, definitely the body should be in contact, no ma. The body should be in contact. Okay, I'll tell you, I'll give you one more way. Another way, I'll follow the same code. Suppose body in contact with this, and somebody is trying to pull it like this. Okay, somebody is trying to pull it like this. Then how will be the tension, ma? How will be the tension means, always remember, whenever tension comes now, you put two arrow marks like this. You put two arrow marks like this. How can I put arrow marks, ma? I can put arrow marks like this, or I can put both the arrow marks like this, or I can put both the arrow marks like this, or I can put both the arrow marks like this. Correct or not? These are four possible ways, right? Two arrow marks. This one you should put. This one you should put. I forgot to tell one more force. That is spring force is there, ma. Add that in the first list. Add that in the list first. Spring force. Spring force, very important. First list I gave you 5 formulas, right? There you add sixth one, spring force. Spring force. Formula anybody? Formula anybody?
Minus kx.
Good. Minus kx, ma formula. Formula is minus kx. We'll see what are they. We'll see what is k, what is x. We'll see. But spring force is minus kx. We'll discuss that direction. Tension, how you should draw, ma? You put two arrow marks. Sir, what is the meaning of two arrow marks? What is the meaning of two arrow marks? Is this number 1, number 2, right? Number 1 is tension acting on what, ma? the object, whatever he is trying to move, and number two is tension acting on what, ma?
The person.
Person. Clear or not? Understood or not? Sir, both of them will have same tension. Same tension will be there. Throughout the string, you will have same tension. Throughout the string, you will have same tension because important point, throughout string, same tension value will be there, same T value will be there. This is what code you will follow, but provided under the assumption string is massless. String will assume massless, then only tension will be same throughout. Clear or not? If string mass, if you consider, if they say massless string, then only, or inextensible, I mean, it should not expand or contract like rubber, like that rubber and all, it should not happen. It should be like pure rope, and it should not expand or contract, and it should be massless. Then only throughout the string, same T value will be there throughout the string, unless some body is connected in between, same tension will be there. Clear or not, ma? How to draw tension? Tension will be always drawn in the strings only. If string is there, then tension force you should think string is there means. How to draw it means you put the two arrow marks in the string. Left one will give you like that two arrow marks like I was telling now, which one will give direction on which one, you will get it. And it will be T only. On both of them, it will be T only because we are assuming string is massless. If string is not massless, then tension will be different at different points. Tension value will be different at different points. We'll see what are they. How to do that, not required further now. That will come in advanced level only. Clear or not, mom? Massless strings. Whenever you read the question, more in your textbook, you will see massless string only. Clear? Now see, I'll give you one more situation. This is the situation, okay? How many strings are there? How many strings are there?
Two.
Two strings are there, correct or not? What did I ask you to do? I asked you to put two arrow marks like this, correct or not? I asked you to put two arrow marks like this. Whenever you see string, you put two arrow marks like this. Then let's say this is body 1 and this is body 2. Both the tensions will be same or not, ma? Here and here tensions will be same or not? No. Okay. There are two different strings. No, sir, it's the same string. No. We are connecting. There is a body in between, right? So there are different strings. Okay. So here T1 will be there. Here also T2 will be there. Now tell me on body 1, what is the direction of T1? On body 1, what is the direction of T1? On body 1, what is the direction of T1? On body 1, what is the direction of T1, ma?
Downwards.
Why, ma? Body 1 means what? This only, no? Okay. In this, there are two arrow marks, no? Here, this is one arrow mark. There are two arrow marks. No, which arrow mark we should consider for body 1? Which arrow mark we should consider, ma, to body 1?
Second one.
The upward one, right? Upward one only we should select. No. So on body 1, what is the direction of T1, ma?
Upwards.
Upwards. Okay. On the ceiling means this one. Ceiling. On the ceiling, what is the direction of T1? What is the direction of T1 on the ceiling? It will be
Downwards.
downward. Clear or not, ma? Next, on body 1, what is the direction of T2? On the body 1, what is the direction of downwards. On the body 2, what is the direction of T2? Upwards. If you draw arrow mark, you can easily tell understood or not, or else up or down variation will become confused. Clear or not, ma? If you don't draw, you might think or you might feel difficult. Just draw the 2 pair of arrow marks. Easily you can tell which body, which arrow mark you have to see. Tension will be acting on the ceiling, tension will be acting on the body 1, tension will be acting on the body 2. On which body both T1 and T2 acts?
Body 1.
Body 1 only. Sir, on body 2 T1 will be there or not? On body 2 T1 will be there or not? T1 will be there or not on body 2? T1 acts on body 2 or not? Question is. Don't think too much, okay? You just follow arrow mark, ma. Don't think too much. Don't think too much, sir. Body 2 also is, is held by actually string 1 only. No, that much you should not think, ma. Understood or not? Okay, simply you should tell string 1 is in contact with body 2 or not? String 1 is in contact with body 2 or not, ma? Not contact. Then T1 will not be there. Then why I am saying body 1 has both T1 and T2? Why I am saying both T1 and T2 will act on first body?
It is in contact with both
It's
the
in contact with both the strings. You just see that. Don't think too much. Again, I am saying don't think too much, sir. That body 2 will take the weight. I mean, body 2 effect will be there on string 1. No, so T1 will act on string 2 is general discussion. It's correct. General, we do physical activity. It's correct, but not here. Clear or not, ma? T1 acts on body 2 or not? T1 acts on which one? Tell me. T1 acts on which one?
body 1 and ceiling.
Body 1 and ceiling. T2 acts on which one?
Body 1 and body.
Body 1 and body 2 also. Correct or not? Body 1 and body 2. Because that string is connected between those two things only. No. Don't think too much. There extra thinking you should not do. Why did I mark both as T1? Why did I mark both as T1? Tell me.
We are assuming the
We
string
are
to be
assuming
massless.
string is massless. That's why. Or else it will not be same. It will not be same because at different locations, string will be.
About the
Tell me. Tell me. So it doesn't matter where I am drawing the arrow mark, correct or not? It doesn't matter where I am drawing the arrow mark. What does that mean? The small doubts you will get later. So I am discussing now itself. This much length is there, ma. Sir, where should I draw the tension? You can draw it here. You can draw it here. You can draw it here. You can draw closer also. If somebody gives you, let's say some points are given. They'll give you 0.1, 0.2, 0.3. Where tension is more, ma? Where tension is more?
It's all the same, sir.
It's all the same. Generally, what will you think? General discussion, where tension will be more? General discussion. I'm not asking you in textbook. You should not follow that. Okay. Where tension will be more? Easy. Come on. You are only pulling it, ma. Where tension will be more? Guess. Or you go and try to pull something. You'll understand. Tie some thread to it and pull it. You'll understand. Where tension will be more? If you are pulling it.
2, sir. Point number
It will
2.
be at 1. Okay. It will be at closer to the body. Tension will be closer to the body. Tension will be more. I think far away tension is more. Because this mass also gets added up, right? This mass also gets added up, no ma. Understanding or not? That string mass will get added up, no. where more mass will get accumulated. If you are pulling it, T3 location la tension will be more. Okay, because I am telling that string mass will get added up. Okay, fine. If it is since we are assuming massless, what is the answer, ma? Textbook, if they ask, see whether the string is given. Mostly they'll give you string massless only. So T1, T2, T3 at all locations, tension will be same. How to draw the directions at every place? At every place you maintain this only. At every place you maintain this only. Why I am drawing 2 arrow marks? Because string definitely it will be connected between 2 bodies. What if string is not connected between 2 bodies? What if string is not connected between 2 bodies? Tell me. What if string is not connected between 2 bodies? I mean, suppose one body is there here and one thread is hanging here. Tell me. The string is not connected between 2 bodies, correct or not? It is connected to one body only. Or you are not holding it also, correct or not? Then what will be the tension in it?
0.
0. Here you need to take tension 0. Tension will come to the rope only when it is in contact with 2 things. Either it will be wall or body, or body or body, or something. It should be in contact between 2 people, or person or body. If simply it is like I mean if it is not like separately it is there, it was left like this. Slack also they'll say slack, or it is just left like that, then no tension. Even though, sir, it looks straight, no, it looks straight, so I think it is tightened, no. Okay, suppose you keep a body, some thread is there to it, it is just simply lying on the road like this. Nobody is trying to pull it, then tension is 0, ma. Understood or not? Tension is 0, then it should be in contact between 2 people. So what is the direction of tension? What will you tell direction of tension? There is no universal statement, okay? But one thing you can remember is tension is a pulling force. Tension is a pulling force. You can't tell like how I told, like last 3 situations I told. No, you can't. Centripetal force I already taught you, no, ma? Correct or not? How to draw centripetal force? How to draw centripetal force?
Towards the center.
Towards the center of the
Just
body.
draw towards the center, okay? Always draw towards the center. Must see where is the body and draw towards the center. See where is the body and draw towards the center. If it is here, draw towards the center. If it is here, draw towards the center. If it is here, draw towards the center. If you are going on the road, suppose you are going on the road, you are taking turn and vehicle is like this. Vehicle is here, it's taking turn. How you should draw a centripetal force? How you should draw centripetal force? Where will be the center for it?
Towards the center.
Where will be the center for it, ma? Towards the center. I didn't draw full circle, but you know where will be the center, right? If I don't draw full circle also, you will know where will be the center, correct or not? How? You will imagine that circle will complete this side. So center will come here. So centripetal force will be like this. Clear, ma? Centripetal force will be like this. Got it? Understood? Yeah. Spring force we'll discuss next class. Any doubt? Please remember and come. Please remember and come. Bye.
Thank you, sir.